figures. That vocab word we're going to talk about is the word similar. Figures are similar if they have their corresponding angles congruent. What that means in more plain words, that means they are the same shape, but not always the same size. So you can kind of see them in these diagrams that are below. Those triangles are the same shape as one another, but clearly one is bigger than the other. That's all that similar means. Same shape, different sizes. The important thing we need to know when we call figures similar is that their sides of similar figures are going to be proportional. So this is a super proportion heavy lesson today. We're going to be doing all proportions today. And we are going to be looking at things called similarity statements. That's this guy right here. What this reads as is triangle ABC. This little squiggle in the middle means is similar to triangle DEF. So we're pretty much going to assume that all of our shapes that we're going to talk about today are similar. And then using that information, we're going to set up those proportions. So what this looks like. The reason we have similarity statements, like in example 1, it says it in the diagram below, triangle ABC is similar to triangle DEF. What is the length of AC? The reason we write these similarity statements out is because we can tell based on the order of the letters what pieces go together with what pieces. So that means A and D correspond to one another. B and E correspond to one another. And then C and F correspond to one another. So I kind of color-coded this a little bit for you so you can see, but that order that those letters are in corresponds to the pieces of the triangles. What's nice about these two triangles in particular, they're drawn in the same orientation, they're flipped the same way. Not always the case as we get in later into geometry or maybe on your homework, you might see that as well. So just pay attention to those letters. That being said, we're going to look at our question. We're going to determine what is it that we're looking for. And in this question, it says, what is the length of AC? So I'm going to call that my variable. And then wherever AC is in my diagram, I'm going to put that X right there. So there's AC. Then to solve, I'm using proportions. We know a proportion is a fraction that's equal to another fraction. So I'm going to draw that proportion out. And then we're just going to line up some pieces. We've done these proportions a lot. Remember, the most important part about setting up your proportion is that you're lining up the pieces. So maybe help yourself out. Call this triangle number 1, triangle number 2. So when I line this up, triangle number 1 and triangle number 2, we're lining up corresponding pieces in the rows, right? The first thing I'm going to do is put in something that I know. I want to put in two sides that are given to me. I know they correspond to one another. So in this diagram, the only two sides that are in the same spot and that I know both of the values of are going to be 16 and 14. Do you see how they're in the same spot? That's going to go first into my proportion. 16 on top with triangle 1, 14 on the bottom with triangle 2. Then I got to put in X. We see that X is in the triangle 1, so I want to make sure that it goes up in the top where triangle 1 is. And then what piece corresponds to the X, but in the second triangle? That should be 18. That's our setup. Any questions on that setup? Now, how do we solve proportions? James, cross multiply. That means I'm multiplying in an X pattern. So the 14 times X is 14X. I put an equal sign in the middle, and then whatever 16 times 18 is goes on the other side of that equal sign. That's 288. Good. Any questions on that? Then that should just be solving. Solving for X. I'm going to divide both sides by 14. This is X equals, I'm not going to get a nice number, 20.57. And then usually we are given some kind of measurement, centimeters, inches, whatever it is. In geometry, we really, really like measurements. So I'm going to call this 20.57. In this case, I'm just going to call it units. You might have inches, you might have centimeters, feet, whatever it is. Any questions on that? Okay, so let's do another one. Again, I'm looking at this similarity statement, the thing with all the letters. I'm lining up. Okay, there's R and M. There's S and N, and then there's T and P. Those pieces line up. I know the length of RS is going to be my X value. So I look at where is RS, R to S, in my triangle diagram. That's where the X goes. And then I need to set up my proportion. What do we want to put first into this proportion? 16 over 12. Perfect. I'm looking for pieces that go together where I have both sets of information. Okay, 16 in the first triangle, 12 in the second triangle. Then where am I going to put X? Am I going to put this in the top or the bottom? It's going to go in the top with the 16. Oops. X. And then in the bottom should go the 9, that corresponding part. Okay, there's my setup. I cross multiply. 12x equals 16 times 9 is 144. I'm going to divide both sides by 12 to get x is 12. And again, I don't have inches or centimeters or anything, so I'm just going to call this 12 units. Any questions on that? Okay, my favorite part about teaching geometry is that I get to draw funny pictures, so I'm very excited that you guys get to see my drawing skills. For example 3, we have a man who is 6 feet tall standing next to a flagpole. The man's shadow is 3.5 feet, and the shadow of the flagpole is 17.5 feet. What is the height of the flagpole? I am really looking for your pictures in this lesson. I'm looking for drawings, diagrams, and I'm looking for proportions. I don't care that you can get the right answer some other way. Those are the two things that I'm really looking for. So, I'm going to draw a flagpole with a shadow, and I'm going to draw a man who also has a shadow. Then I'm going to start labeling some stuff, right? I have a man who is 6 feet tall. So here's the man, he's 6 feet tall. The man's shadow is 3.5 feet. So this is 3.5. The shadow of the flagpole is 17.5. There's the shadow. What is the height of the flagpole? Remember that question that's being asked? That's going to be our variable x. I'm going to put x over here as the height of my flagpole. If we think about these as triangles, we're going to assume that these triangles are similar. And then with that information, we're going to go ahead and we're going to set up our proportion. Oops. So let's start with, of course, the information that we know. What's going to go first in this proportion? Perfect. The two shadows are going to go together, 17.5 and 3.5. These are shadows. Then on the other side, I know I'm looking for x. I have to line up x, the height of the flagpole, with the length of its shadow. So here's flag. So this has to go with the height of the flag x, which means the last part I need to fill in is going to be the height of the man, which is 6. We cross multiply. 3.5x equals whatever 6 times 17.5 is. 105, thank you. Solve it, divide by 3.5 to get x equals 30. And I should have a unit here. What is my unit in this problem? Feet, perfect. Any questions? Okay, you guys are going to love this one. We're going to do a 6-foot tall tent standing next to a cardboard box. I don't know what kind of shady back alley we're in, but there's a tent and there's a cardboard box. So let's draw that tent. Oh, look at that. That's perfect. And then I'm going to draw a cardboard box. It's going to be really good. Oh, I need some more room, actually. Oh, that's perfect. Look at that cardboard box. Okay. We got our tent and we got our box. Let's label them. They both have a shadow, so let's draw their shadows. You can't draw your box? No. Oh, okay. Well, try your best. The tent is 6 feet tall. So that's a 6 here. and it casts a 9-foot shadow. There's my triangle. The box casts a 6-foot shadow, and we don't know how tall the box is, so that's going to be our x value. Everybody got it? Everybody got it? Proportion time. What's the first part of our proportion? 9/6, these two parts that go together. We're talking shadows. Shadow of the box, shadow of the tent, shadow of the box. Then what? 6/x. We have the height of the tent and the height of the box. The most important part is that we are lining up these pieces. So if you got to write like the grid, then do that. Cross multiply. 9x equals 36. We divide by 9. X equals 4. What's our unit on this? Feet. Good. Any questions on that? Okay, we're going to pivot just a little bit, but we're not going to do anything too different from this. Go ahead and flip it over. We're going to get through them. All right, similarity is used all the time in the real world. For example, it is used on maps, 2-dimensional models, 3-dimensional models. For all of these maps and models to be miniature versions of the real life, we use something called scales. A scale is a ratio, so usually you're going to see it look something like, I'll show it to you in the first problem. It looks something like this. You've probably seen like a map before where it says 1 inch to 110 miles, something like that. That's what a scale is. And actually, I think problems that give you this scale are a little bit easier than problems where you're not given a scale because the first part of my proportion is kind of already set up for me. So in example 5, we're talking about the distance from Jacksonville to Gainesville on a map versus in real life. The first part of my proportion is going to be this scale. So I'm going to put 1 inch and 110 miles. And I'm purposefully leaving those units in there because it's going to help me set up the rest of my proportion. Because I know that inches are going to go along the top and miles are going to go along the bottom. So the only other piece of information I have in here is that the distance on the map is 0.6 inches. So I have the map and I have the real distance. So if the map distance is 0.6, I want to know what the actual distance is from Jacksonville to Gainesville. That's x, and I can cross multiply. Do you see how it makes it so super easy when we already have that scale for us? We can just plug that right in. So then I have 110 times 0.6 is, what did I write down? 66. And then what's our unit on this? It's in the same line as the miles, so I know that my unit should be miles. Questions? Okay, let's keep going. Let's rapid fire. The distance between Milwaukee and Nashville is 568 miles. On a map, Milwaukee is 2.5 inches from Nashville. What is the scale? Proportion first. I don't know the scale. So that whole first part over here where I usually put the scale, I got to leave that blank for right now. Let's fill in what we do know. What I do know is that on a map, the distance is 2.5 inches. And then in real life, that's 568 miles. Everybody good with that? The important part about scales is that they always start with a 1. So I want how many actual miles is 1 inch. So I have to start with that 1 inch. Maybe put a star on it so you remember that. Then I want to know what is the scale. So that's where I'm going to put my x, in that last spot. I want to know 1 inch equals how many miles on my map. So there's our setup. We cross multiply. I'm going to divide by 2.5 to solve for x. And that's going to get me, oh, not a nice number, 227.2. That should be in miles. And then the problem is asking me for the scale. So I want to make sure that I answer the question it's asking me. The scale is 1 inch to every 227.2 miles. Good? Okay, let's rapid fire 2 more. A scale model of a building is 6 inches tall. The scale of the model is 1 inch to 25 feet. What's the actual height of the building? Help me set this one up. What goes first? Perfect. I'm going to leave that with its units so that I can make sure that I'm lining pieces up. Then what else can I put in here? The 6 inches has to go with the inches. The x, the actual height of the building in feet, is what goes on the bottom. We cross multiply. That's x equals 6 times 25, 150. Look at that. I don't even have to solve anything. What's my final unit here? Feet. Perfect. Oh, hello. Okay. One more. A model house has a scale of 1 inch to 2 feet. If the real house is 26 feet wide, how wide is the model house? Set up. 1 inch over 2 feet. There's my scale. Then what goes in the other side? X on the top, because I don't know how many inches. Model house is an X. And then 26 feet goes with the feet on the bottom. Cross multiply. 2x equals 26. X equals 13. What's my unit? Thank you. Any questions?